Hello student, good morning. Dear student, now today you will study in this online class of physics part 10th. Chapter is sources of energy and topic is here today fuels. Okay. Dear student, in the previous video I told you about the sources of energy. Sources of energy is one that which can produce the adequate amount or the sufficient amount of heat energy in the conventional form over a long period of time. Dear student, I told you what is the sources of energy. Sources of energy is just like here the fuels, fossil fuels. Fossil fuels are the sources of energy, and ultimate sources of energy is sun also. And dear student, I told you there are two categories. All the sources of energy which are categorized in two categories. One is the renewable sources of energy, and second is the non-renewable sources of energy. I told you what is renewable and what is non-renewable, and renewable sources of energy which are called, that is the conventional, and that is also where the inexhaustible, but non-renewable sources of energy is what? Exhaustible sources of energy. I told you, and what is the best example in renewable sources of energy and non-renewable sources of energy. In renewable sources of energy which can regenerate again and again after using, just like here the wood, solar energy, water energy, hydro energy, wind energy, these type of energy which are called renewable sources of energy are inexhaustible sources of energy. But here the fossil fuels, coal, petroleum, natural gas, which are in non-renewable sources of energy, which cannot be regenerated again and again, which are not present unlimited amount, which are present limited amount in our nature or in our surrounding. Now today you will study here the fuels. What is the fuel? Okay, dear student, fuels, the material which are burned, the material or substance which are burned to produce the amount of heat energy. The material which are burned to produce heat energy are called fuels. Okay, the material which are burned to produce heat energy are called fuels, just like the wood, coal, petroleum, natural gas. Okay, these are the fuels. And here the fuel, the material which are burned to produce heat energy is called, are known as fuels. The material which are burned, the materials which are burned to produce heat energy, burned to produce heat energy. Burned to produce heat energy are known as fuels. Okay. Dear students, the materials which are burned to produce heat energy are known as fuels. The examples of a fuels, first example is here wood. Okay, when the wood is burned, now it produces heat energy and light energy also. First the light energy, then amount of heat energy, and second is coal. Coal, know that, and they have a types of coal, just like the bituminous and anthracite, and coal is here, and charcoal. Here the coal is also the fuel which burn and produce the heat energy, and diesel and petrol, LPG is what? Liquid petroleum gas. LPG, which are also used as a fuel to produce heat energy. Okay, there are so many fuels, and in which some produce high amount of heat energy and some produce less amount of heat energy. Because which have the high calorific value, that fuel produce the high amount of heat energy, and which have the less amount of calorific value, just like the not here high calorific value, less amount of calorific value, which produce the less heat energy. So the heat energy produce high, which are depend upon calorific value and in lesser temperature also. LPG and diesel, petrol. Okay, these are the fuels. Dear friend, the material which are burned to produce heat energy are known as what? Fuels. For example, this is wood, coal, petroleum, diesel, LPG. These are the fuels. Dear friend, I told you here calorific value. Calorific value. Here the fuels, because there are so many fuels and which produce high amount of heat energy and less amount of heat energy. Okay. And here dear student, calorific value is what? Dear student, calorific value, the amount of heat energy which is produced by burning. But when a unit mass of a fuel burned completely, it means here the amount of heat energy produced by burning a unit mass of a fuel completely is known as calorific value. Okay? Yes, sir. What is the calorific value? The amount of heat produced by burning a unit mass of fuel completely. Calorific value. Calorific value. What is the calorific value? The amount of heat. The amount of heat produced by burning, the amount of heat produced by burning a unit mass of fuels completely called calorific value. What is the calorific value? The amount of heat energy produced by burning a unit mass of a fuels completely is known as calorific value. Is known as calorific value. Calorific value. Dear student, a fuel which have calorific value, which is a good fuel, or better fuel, which have a high calorific value. Hydrogen gas, which have a highest calorific value which are measured in kilojoule per gram. So the commonly unit of calorific value is kilojoule per gram. This is the unit of calorific value, kilojoule per gram. Highest calorific value of hydrogen gas, which is hydrogen gas, which has calorific value 150 kilojoule per gram. This is the highest calorific value, okay, of a hydrogen gas. So the hydrogen gas is the best fuel because which have a highest calorific value. Okay, dear friend, it means what? If a hydrogen gas has 150 kilojoule per gram calorific value, what does mean it? It means that when the 1 gram of hydrogen gas burned completely, now it produces 150 kilojoule heat energy. It means that when the 1 gram hydrogen gas burned completely, now it produces the amount of heat 150 kilojoule. Okay, you will get for one very short question. If the calorific value of kerosene oil is 48 kilojoule per gram, what does mean it? It means that when the 1 gram of calorific, here the kerosene oil burned completely, now that produce the amount of heat energy 48 kilojoule. Okay, that produce 48 kilojoule amount of heat energy by burning of unit mass of a fuel, of a kerosene oil or any other fuels. Now you will see here some fuels and their calorific value. Okay, what is the calorific value? The amount of heat energy, okay, the amount of heat energy produced by burning a unit mass of a fuel completely is known as calorific value of a fuel, which is measured in kilojoule per gram. It means if the 1 gram of substance or the unit mass of a substance of a fuel completely burned, now it produces the amount of heat energy 1 kilojoule. Here the highest calorific value of a hydrogen gas is 150 kilojoule per gram. It means that when the 1 gram of hydrogen gas burned completely, now it produces 150 kilojoule amount of heat energy. Okay, now you can define in other way. Just like here, 150 kilojoule amount of heat produced by burning of a unit mass of a substance are the fuel hydrogen gas. Okay? Or when the 1 gram of fuel of a hydrogen gas burned completely, now it produced the amount of heat energy is 150 kilojoule. This is the calorific value. It is very important point. Calorific value, which are measured in kilojoule per gram, unit mass of a substance. And the fuel which have the highest calorific value, that fuel is the best fuel. Okay? Now you will see here some fuel and their calorific value. Dear student, here the name of the fuel first of all, dung cakes. Dung cake. Dung cakes. First, this is the name and calorific value is here. Calorific value in kilojoule per gram. Second point is here, wood. Third is here, coal. Fourth is here, charcoal. Charcoal. Okay. Fifth is here, alcohol. Alcohol. And sixth is here, diesel. 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 And next is here, kerosene oil. Kerosene oil. Okay. Now here you will see that first there, then after you will see some other fuels. Cow dung, which calorific value is 6 to 8. 6 to 8 kilojoule per gram. Okay. And the wood, which have the calorific value is 17 kilojoule per gram. And then after coal, which had the calorific value is 25 to 30 kilojoule per gram. And charcoal, which had 33. Okay, alcohol, which had 30. And diesel, which had 45. And this is 48. Okay. Once again, cow dung are the dung cake, aruple, which have the calorific value is 6 to 8 kilojoule per gram. Wood, and which have the calorific value 17 kilojoule per gram. Coal, which have the calorific value 25 to 30 kilojoule per gram. Charcoal, which have the calorific value 33 kilojoule per gram. Kilojoule per gram. This is per gram. This is kilojoule per gram. Kilojoule per gram. And kilojoule per gram. Here student here, 33, which have here charcoal. Alcohol, which have 30 kilojoule per gram. And diesel, which have 45 kilojoule per gram. 45. This is it. You can write here. This is 45 kilojoule per gram. Which have diesel. And kerosene oil, which have 48 kilojoule. 48 kilojoule per gram. What does mean it? I told you, if the 1 gram of diesel oil burned completely, now it produces 48 kilojoule amount of heat energy. Okay? Calorific value is what? The amount of heat energy produced by burning of unit mass of a fuel completely is known as the calorific value. When the 1 gram of kerosene oil burned completely, now it produces 48 kilojoule amount of heat energy. This is it means that. I told you the highest calorific value of which fuel? Hydrogen. 150 kilojoule per gram. 150 kilojoule per gram. Now you will see some other fuel and which have their calorific value. First of all here, petrol. Next is biogas. Next is LPG. What does it mean LPG? Liquid petroleum gas. LPG. And natural gas. Natural gas is also known as CNG. Natural gas. Okay. Methane. Methane gas. And hydrogen gas. Hydrogen gas. Okay. Here dear student, you will see that calorific value of petrol, which is 50 kilojoule per gram. It means when the 1 gram petrol oil is completely burned, now it produces 50 kilojoule amount of heat energy. And biogas is 35 to 40 kilojoule per gram. Biogas which have 35 to 40 kilojoule per gram. Dear student, you will write in your notebook and then after you will learn what is the calorific value of these fuels. In which the important some fuels just like the biogas, CNG, petrol, diesel and kerosene oil, hydrogen gas and charcoal and coal also. Okay, and so you will maintain this observation in your notebook and then after you will learn it. Biogas, natural gas which have 33 to 50, natural gas which have 33 to 50 kilojoule per gram, 33 to 50, and LPG which have 50 kilojoule, 50 kilojoule per gram. Methane which have 55. I know that hydrogen 150. This is kilojoule per gram, kilojoule per gram. Okay. Once again, what is the calorific value of petrol? 50 kilojoule per gram. What is the calorific value of biogas? 35 to 40 kilojoule per gram. Calorific value of LPG? 50 kilojoule per gram. Calorific value of natural gas? 33 to 50 kilojoule. This is also called CNG, compressed natural gas. And here the methane, 55 kilojoule per gram. Hydrogen gas, 150 kilojoule per gram. I told you the highest calorific value of the hydrogen gas, 150 kilojoule per gram. It means that when the 1 gram fuel of hydrogen gas burned completely, now it produces the amount of heat energy 150 kilojoule. Okay, now you can write. If you will get the question, what does mean it? Now you will write, it means that, you will take any question, it means that, it's like here the biogas, when the 1 gram of biogas burned completely, now it produces the amount of heat energy 33 to 40 kilojoule. 33 to 40 kilojoule. In the same way, just like here, if the 1 gram of, what is this? Methane. 1 gram of fuel of methane gas burned completely, it produces 55 kilojoule. It produces 55 kilojoule amount of heat energy. In the same way, you will define here, if the 1 gram of LPG, liquid petroleum gas, fuel burned completely, it produces 50 kilojoule amount of heat energy. Okay? It produces 50 kilojoule amount of heat energy. So you will get one question for the very short answer. What does mean it? Now you will define it. Means that when the 1 gram or the unit mass of a substance of this fuel burned completely, now it produces the amount of heat energy is what? You have given the amount of heat. Whatever you will take these substances or these fuels, you can define. Just like here, what does mean it? If the methane gas has the calorific value 55 kilojoule per gram, now you will define it. Means that when the 1 gram of or the unit mass of a methane gas fuel burned completely, it produces the amount of heat energy 55 kJ. Okay.